Electric cars change transportation forever. So why can't we just put batteries on a plane and call it a day? The answer isn't technology, it's physics. And solving it might change aviation forever. Let's start with the core problem: energy density. Jet fuel contains about 12,000 watt-hours per kilogram. A modern lithium-ion battery? About 250. That is 48 times less energy per kilogram. For a Boeing 737 carrying 20 tons of fuel, you would need nearly 1,000 tons of batteries to fly the same distance. It won't fly. The aircraft would be too heavy to leave the ground. And it's not just weight. Batteries don't get lighter as you use them. Jet fuel burns off during flight, making the plane lighter and more efficient as the journey progresses. Batteries stay heavy the whole trip. That's why electric cars work for daily commutes but not for crossing oceans. Current battery technology limits electric aircraft to short hops, maybe 200 to 400 miles with a small payload. That's great for regional flights, training aircraft, or air taxis. But for the 95% of emissions that come from medium and long-haul flights, batteries alone aren't the answer. So if batteries can't power a 777 across the Pacific, what can? The solution isn't one technology, it's a portfolio. And it starts with something you can use in your car today: sustainable aviation fuel. For the long term, two technologies offer true zero-emission flight: hydrogen and electric. But they solve different problems. Hydrogen has incredible energy by weight 3 times that of jet fuel. But it's bulky. Storing it requires cryogenic tanks at minus 253 degrees Celsius. That means redesigning the entire aircraft. Airbus's ZEROe concepts show what's possible: blended wing bodies with hydrogen tanks in the fuselage. But they won't fly commercially before 2035. Electric aircraft are happening now, but for short ranges. Companies are developing 30 to 50-seat electric planes for regional routes. And eVTOL air taxis? Those are electric by design. The technology works. The challenge is certification, infrastructure, and public acceptance. Hybrid electric might be the bridge between today and tomorrow. A small turbine generates electricity to charge batteries or power motors. You get the range of fuel with the efficiency of electric. Rolls-Royce, Airbus, and startups are testing this now. It's complex, but it could unlock medium-range, zero-emission flight. Each technology has a role. Electric for short hops, hydrogen for long haul, hybrid for the transition, and SAF to decarbonize the fleet we have today. The question isn't which one wins. It's how they work together. Enter Sustainable Aviation Fuel, or SAF. It's not a new engine. It's a new fuel that works in existing engines. SAF is made from renewable sources: used cooking oil, agricultural waste, forestry residues, even captured carbon dioxide and green hydrogen. And it can reduce life cycle emissions by up to 80%. Here's the key: SAF is drop-in compatible. No engine modifications. No new infrastructure. You can blend it with conventional jet fuel today. Airlines are already using it, like United, Delta, Lufthansa, and Air France. The challenge isn't technology, it's scale and cost. Right now, SAF makes up less than 0.2% of global jet fuel. To meet 2050 net zero targets, we need to scale production by 500 times. That requires investment, policy support, and new supply chains. But it's the most realistic path to decarbonizing existing fleets. And SAF isn't just about carbon dioxide. It also reduces contrail formation. Those white trails that trap heat in the atmosphere. Some studies suggest contrails cause as much warming as aviation CO2. So SAF could cut aviation's climate impact by more than just emissions. Think of SAF as the bridge. It works with the aircraft we have today. It uses the infrastructure we've already built. And it buys us time to develop the next generation of zero-emission technology. But what comes after the bridge? So what's the realistic path? It's not one technology. It's a portfolio. Sustainable aviation fuel will carry the load this decade. It's deployable now. Hydrogen will transform long-haul by the 2040s. Electric will revolutionize regional and urban air mobility. And operational improvements: better routing, single-engine taxi, continuous descent, squeeze out every last percent. And here's the good news: you won't notice the difference. Same cabin, same comfort, same safety. The revolution happens behind the scenes in refineries, labs, and design studios. Your next flight could already be using SAF. And in 20 years, it might run on hydrogen. Decarbonizing aviation isn't about giving up flight. It's about reimagining it. The technology exists. The will is growing. And every viewer who understands the challenge is part of the solution. If this changed how you see the future of flight, hit subscribe. We've covered 9 fundamentals and we're just getting started. Drop a comment. Which solution excites you most, SAF, hydrogen, or electric? And what topics should we tackle next? New videos every Tuesday. Tap subscribe so you don't miss what's next. Thanks for watching, and I'll see you in the next one.